Okay, so what is a translation? Well, we can watch this YouTube video and it gives us a quick demonstration, but it's more like a slide. All right, you're just really going to be sliding shapes around a coordinate plane. So a translation is a rigid motion. Remember, rigid motion means preserves angle and side measure. So nothing about the shape changes. It's still going to have the same orientation, even. It's just the literal space it's in is all that changed. So it's a rigid motion in which all points of figure are moved in the same distance in the same directions. And it's sometimes informally referred to as a slide. I already told you that. Okay, so we have the English language and we can say like left 3, down 5, but we also have coordinate notation, and just the notation we use in a coordinate plane. So some random point x, y, well, you can move x, so this is going to be horizontally a amount of units, and y plus b amount of units vertically. All right, so that means that if the preimage, or if the point in the preimage is given by the coordinates x, y, then the corresponding point in the image will be shifted a units horizontally and b units vertically. All right, so here's just a classic example from an old test. Who really cares? From 2009. I think dinosaurs still walked the earth in 2009. That was such a long time ago. However, let's just get after it. We're going to translate the figure 3 units to the left. All right, so the left is this way. So when you move in a coordinate plane, this is going to be x minus 3. We're going to the left, so it's going to be minus and 5 units up. So that means we're going to be adding 5. And we'll see the difference when we go plus and minus and stuff like that. It's a lot of just common sense. All right. So s is at -1, 2. So we don't even really have to look at the shape. We can just think about plugging -1 in there. -1 minus 3 is going to spit out -4. 2 plus 5 spits out 7. So you can literally just do math that way. All right, so we're going to have 1, 2, 3, 1, 2, 3, 4, 5. Boom. All right, so you saw me do it the other way in the coordinate plane where I literally just counted it out. All right, now we'll pick it up a little bit. I can also look at this way and just look at R. 1, 2, 3, 1, 2, 3, 4, 5. All right, something I forgot to do as I was going is labeling my points. I have S prime, oops, R prime. All right, and while I'm here, let's see, R was at 0, -7. And then U will be at -2, 1, 1, 2, 3, 1, 2, 3, 4, 5. And I'm just going to keep doing it both ways because you guys are brand new at this, so you can see it as much as possible. And then R prime would be, oops, I made a slight mistake, but I will overcome my mistake. Where I did T, that's where I should have put R. And it's okay to make mistakes, especially when we catch them. All right, so it's not really that big of a deal. All right. Got a little distracted. All right. There we go. So T will be 1, 2, 3, 1, 2, 3, 4, 5. So T is at 0, 6. And I realized I made a double mistake. That point was -7, 0. It's okay though. Everything's fixed. Hopefully you're realizing my mistakes as I was going. All right. As much as I like to try to be perfect, definitely not. But what's good about it is I realized my mistakes, overcame them. Math teaches life lessons. All right. So that's just a traditional one. Really, all my mistakes was as I didn't pay attention to detail. Just make sure you pay attention to detail, making sure you're doing the right point when. All right. And then we're going to have some logic problems where point A is the preimage. All right, so A, we can just remind ourselves that's where we start. And it has 6, -1. A prime is where we ended. All right, -2, -2. We got to describe the translation that occurred. So what I have to think here is, what did I add or subtract to 6 to get to -2? Well, that'd be -8. And then, what did I add or subtract to -1 to get -2? Well, that's a -1. All right. Something I forgot to mention, but translations is just adding. In parentheses, I'll put subtraction. Technically, you could say subtraction doesn't exist. Subtraction is just adding negative numbers. But nonetheless, all right, so we're going to put it in, just describe. So we can say easy as left 8 down 1. Or we can put it in coordinate notation. And please realize this whole thing is the coordinate notation. This whole thing is the coordinate notation. This whole thing is the coordinate notation. All right. X, Y, arrow, x minus 8, y minus 1. Students like just to put the left, or excuse me, the right part of it, which isn't the whole thing. All right. You have to put the whole thing. That's just how it is. That's how you input to a computer if you wanted to. All right, in this problem right here, I love this point. I'm just gonna take out some information. We got this first one. All right, this maps t to t prime. A transformation x, y, arrow, x plus 4, y minus 1 maps t to t prime. All right, then t prime to t double prime is this right here. All right, so we can do a double translation. You move the point, then you can move the point again. All right, that's definitely mathematically legal. To combine it as 1 from t to t double prime, you're just really bashing it all together. You're gonna have x plus 4, minus 7, comma. So you're taking the plus 4, minus 7, bashing it all into 1. And then hopefully you can see the pattern where you're just going to do the same thing for the y. Alright, and then you just simplify. Alright, so instead of doing both translations to get to the endpoint, you could do a single translation such as this one right here. Alright folks, so stay tuned for more.